In this video, we're going to be talking about the basic structure of the periodic table. Now, we're going to have an entire unit later on dedicated to all the different properties and everything that you can determine from the periodic table. But for right now, we're just kind of going to get used to the structure of it a little bit. Right, so what I want you to be able to do is understand how the table is structured. I want you to be able to identify which elements on the table are metals and what are nonmetals. And we're also going to go over a list of elements that are diatomic, which means they naturally exist as molecules. Now, the basic periodic table itself is just a listing of all of the elements that we have organized by increasing atomic number or increasing number of protons. Now, when we get to our unit on periodic trends, the shape of the periodic table is actually important, right? But we'll get into that a little bit later. Now, as of now, we have hit 118, right? So that is, as of 2020, we've gotten element number 118. 118 actually is OG for oganesson, right? All the elements up through here have been named. I apologize. This table is a little bit older, right? So not all the elements are named, not all the elements are even on there. But we've filled out through the end of this row right now. But notice, just like any table, you have rows and you have columns, right? And these have specific names. Now, the columns are called groups. There are 18 groups on the periodic table, and what's important about these groups is that all the elements in a group will have similar chemical and physical properties. Right? There are some important groups on the table that you should know about. So group 1 are what are called the alkali metals. This is lithium, sodium, potassium, rubidium. These are all very soft silver-colored metals, and they're all extremely reactive. In fact, if you were to take sodium or potassium and put it in water, it has a tendency to explode. Right, so that's group 1 alkali. On the other side of the table, you have group 17, which are called the halogens. The halogens are all nonmetals, and they're also extremely reactive. So that'd be fluorine, chlorine, bromine, iodine, and astatine. Fluorine is the single most reactive nonmetal in existence. If you put fluorine near anything other than fluorine, it will probably react, and very violently so. Group 18 are called the noble gases. They're called noble because they don't react. These gases are too good to combine with anything else. Right, so they're the nobility of the table. Again, once we get into trends in reactivity, the reason why noble gases are unreactive is because their outer electron shell is completely filled, which is extraordinarily stable, and every element's going to try to become like a noble gas. That's the ultimate name of the game. The rows of the periodic table are called periods. There are currently 7. The only thing remarkable about elements in the same period is that they have the same outer or valence electron shell. Right, so everything in period number 4, its valence electron shell is the 4th shell. So if you remember back from the Bohr diagram, that would be the 4th ring. We can also divide the table by metals and nonmetals. The vast majority of the table, like 3/4 of the table to the lower left, are all metals. The upper right-hand corner of the table are all nonmetals. And if you see this little staircase line right here, right, this little staircase line, all of those blue elements on that staircase line are called metalloids. And those properties are kind of a little bit interesting. We'll cover those a little bit in a second. Right, so we have metals, nonmetals, and metalloids. So let's go over some of the properties of these. So metals, all but one metal is a solid at room temperature. The only exception is mercury, which is a liquid. Metals in their bare state tend to be lustrous or shiny. Right, so for example, if you're wearing jewelry, your gold and silver rings are probably buffed and polished because metals can do that fairly easily. Metals are extremely conductive, both for heat and electricity. That's one of the reasons why metals are used for virtually everything. So the fact that they're thermally conductive makes them very useful as cooking vessels, right? So we can put a pan on the stove, the pan heats up really quickly because metals are conductive, and it will transfer heat very efficiently. And then when we take it off the stove, it cools down rather quickly as well. Right? And also being electrically conductive, that's again why we use them in all of our wiring and everything. Metals are malleable. Malleable means that we can bend it, twist it, shape it, and form it however we want to. And then the last property of a metal is that metals are ductile. Ductile just means you can take a sample and draw it out into a very fine, thin wire. Right? So these are the properties of metals. For nonmetals, they can be either solid or gas at room temperature for the most part. Nonmetals are extremely brittle, so if you hit it, it will shatter into thousands of tiny little pieces. One of the labs we normally like to have you guys do is an element lab where you get to take some of these elements and use a what we call malleability tester, otherwise known as a hammer. And you'll find that as you just even give the slightest tap to a nonmetal, it breaks. Nonmetals are insulators, which means they don't conduct heat or electricity. Nonmetals are often used to keep warm things warm, cool things cool, or in the case of wires, they keep wires from touching. That's why wires are always wrapped in those plastic sleeves. Plastic is a non-metallic material, so it insulates electricity. It keeps the electricity in the wire going in that wire and prevents it from arcing to other wires. Right, so those are some of the properties of nonmetals. Now, for metalloids, or these are also called semimetals, their properties are kind of in between. Right, so all metalloids are solid. That's one of the big things. Right, so silicon, germanium, arsenic, antimony, all of them solid. Metalloids are semiconductive. This is what makes them really useful in electronics. Right, the fact that silicon is a semiconductor basically means that its ability to conduct depends on how much electricity you pass through it. The more electricity you pass through, the more conductive it is. The less electricity, the less conductive. The downside to being semiconductive is that some of the nonmetallic properties come up, and metalloids also tend to be somewhat on the brittle side. Right, so one of the problems with silicon is even though it's a fantastic semiconductor, it's extremely brittle. And it's really hard to make in a very pure form. It's one of the reasons why computer chips tend to be fairly expensive, is making the silicon for it, the silicon wafer, is a very difficult process, and a lot of what you produce isn't actually usable because it's broken. So again, if I give you some properties of an element, I expect you to be able to classify it as metal, non-metal, or metalloid. And the last thing we have on our list is the list of diatomic elements. These diatomic elements are a list of 7, so these things commonly exist as molecules. So that's why I have the X2. Their formula is the symbol of the element with the subscript 2 telling you there are 2 of them. Now, this list of 7 I'm going to ask you to memorize. I reserve the right at any point in time without warning to ask you to list these elements and give you maybe a minute to do so. So please pay attention. Please commit these to memory. It's only a list of 7. It's one of the few things I ask you to memorize. All right, so the first diatomic element is hydrogen, then nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Right, so these are the 7. If you want a nice, easy mnemonic to learn these, just remember that if you are of appropriate age, to have no fear of ice cold beer. So that's it. That's the periodic table video. If you guys have any questions, feel free to contact me. Otherwise, I will see you guys later in class.